So scientists went along, just, discovering elements and stuff, and figuring out what was inside of them and looking at their properties and everything. And after a while, it got a little confusing because there's all these different elements. And scientists like to find patterns in things, and we like to arrange things and classify and categorize. And so Dmitri Mendeleev was trying to find patterns and some order in the elements. And what he observed was what he calls the periodic law, that when you put the elements in order of increasing relative mass, there were certain sets of properties that recur periodically. And this led to the periodic table. Well, we'll just go with what's on the slide here. And so this is a color-coded version of the periodic table, and there's some things I want you to know about it. There is, let me put it in a thick black line, there is a stair-step line going down right here. I will give you a clean periodic table on an exam. And we also have this one on the wall. And you'll see it didn't come with the stair-step line, but somebody drew it in with a marker, which is awesome because we need that stair-step line. That divides the metals and the nonmetals. Here, the green ones in the upper right, nitrogen, oxygen, fluorine, chlorine, sulfur. These are all nonmetals. All of the ones indicated in green on this periodic table are nonmetals. All the ones in yellow are metals. And so this line allows us to identify whether something is a metal or a nonmetal just by its position on the periodic table. Do you notice anybody who's not following that pattern? Well, there's these guys. Oops, didn't mean to do that. There's these pink ones, but there's hydrogen. What's hydrogen doing over there? Hydrogen is like the baby brother of the family. And the baby brother gets away with all kinds of stuff, right? He breaks the rules, and people say, oh, he's so cute, right? So, yeah, hydrogen's over here. That doesn't mean it's a metal, okay? Hydrogen is what they filled the Hindenburg with, right? It's a gas, it's lighter than air, it's also very flammable, unfortunately, for the people riding in the Hindenburg. But that was a big blimp that it blew up long time ago, even before I was born. So hydrogen's over there. We just kind of have to remember some stuff about him because he doesn't follow a lot of patterns. So metals and nonmetals, and then we've got these guys right along the line, and those are the metalloids or the semi-metals. Now aluminum is also right along the line, adjacent to this line. But what do we know from just life experience about aluminum? Is aluminum a metal? Sure it is. We make pots and pans out of it. It's in your car. They make airplane wings out of aluminum. It's a metal. Okay? So we should be able to remember that aluminum is a metal. These other guys are semi-metals, and polonium's an exception to that, but we don't care about him because we're not going to run into him very much. So you should be able to tell me what any of the elements are, metal, non-metal, semi-metal, just by looking at a periodic table. I'm going to go over this fairly quickly because there's just not a whole lot of explaining this. So you just need to read about this in your book. Metals are going to have similar properties, and these are properties that most metals have. They're good conductors of heat and electricity. That's why we make cookware and electrical wires out of them, because they conduct heat and electricity. They can be pounded into flat sheets. You can't do that with everything. When you hit a metal with a hammer, it does not shatter into a million pieces. It dents, and if you keep hitting it, you can cause it to spread out into a sheet. That's called malleability. They can be, metals can usually be drawn into wires. They are ductile. They are often shiny or lustrous. This one's important in chemistry. This one, ooh, that's not a good color. Metals tend to lose electrons. That's important. Metals lose electrons. And looking at the properties of nonmetals. Nonmetals are less consistent than metals are. Some are solids at room temperature, others are gases. They do tend to be poor conductors of heat and electricity, although carbon can conduct electricity. They tend to gain electrons. So that's the most important idea for chemistry here. Nonmetals tend to gain electrons when they undergo chemical changes. Then the ones in the middle, the metalloids, are also called semi-metals. And they're going to have properties between the metals and the nonmetals. So they have mixed properties. They're also called semiconductors. They have sort of an intermediate electrical conductivity, which we can adjust, we can control. And so that makes them really good as little teeny tiny switches in computer chips. We could not have the computers that we have today without semiconductors. So classify each of these as a metal, nonmetal, or metalloid. Oops, didn't mean to do that. S is which element? Sulfur. Metal, nonmetal, or metalloid? I'm hearing metalloid. Nonmetal. So we're just going to look in the periodic table up here on the wall, and it's not touching the line. It's to the right, it's a nonmetal. So we don't have a color-coded chart anymore. If you forget which side of the line is the metals and the nonmetals, pick an element that you know something about. How about iron? Is iron a metal? Yeah. Which side of the line is iron on? The left. So that means that all the other guys on the left are metals. Chlorine, nonmetal. Ti, that's a metal. That's titanium. So that's a metal. Sb is antimony. What's that? Metalloid. We find it on the periodic table, and it is touching that stair-step line that divides them. So that's a metalloid. So you should be able to answer questions like that for the exam. Other information we get from the periodic table, we can divide it into two sections, main groups, the main group and the transition. And so if we look at these two columns here that stick up and these columns over here that kind of stick up, those are called the main group elements. The main group elements are more predictable than these blue guys in the middle here. This part that looks like it kind of sunk down, these are the transition elements. It's like the transition between this cliff and that cliff. Those are the main groups. That's like the mainland, and here's the transition in between. Their properties are a lot less predictable. Also on the periodic table, we have group numbers listed. 1A, 2A, 3B. It doesn't appear to make much sense. We can just safely ignore these guys in the middle. We're not going to use their group numbers at all. But we are going to use the group numbers for the main group elements. And those go 1, 2, and then 3 through 8 straight across the main group elements. We also number the rows from the top down, 1 through 7. And those are called periods. So we have groups and we have rows. We have groups and periods, columns and rows. Some of these groups have special names. And what Mendeleev found was that when you arrange the elements this way, and you see we've got increasing number of protons. So we go 1, and then 2, 3, 4, 5, 6, 7, 8, 9, 10. We jump around here, 11. So they're going in order of increasing atomic number. What we find is that elements in this column have similar chemical and physical properties. And if we look at these guys over here, well, those guys are kind of off the screen too. Let's look at these guys. these guys have similar chemical and physical properties. That's the periodic repeating properties. And so we've given some of these groups names. Group 1A are called the alkali metals. Group 2 is the alkaline earth metals. Over here, group 7A, these are called the halogens. And group 8A are called the noble gases. Anybody wonder about these rows on the bottom here? These guys really belong in here. Notice on this periodic table there's this little gap here, and really we should take a pair of scissors and cut all the way up, spread the two pieces apart, and put these guys back in the middle. But that makes the periodic table really long and skinny, and it doesn't fit on a piece of paper. We don't use these guys very much, so we pulled them out and stuck them at the bottom. But looking at these numbers here, we got 55, 56, 57, 72. What happened there? Well, 57, 58, here's the rest of them. You go all the way up here to 71, and then it jumps back up here. And this periodic table, because we have so little wall space in this classroom, they actually had to cut the periodic table, and these guys are behind the screen, which isn't a big problem because we don't use them very often. But these are called the lanthanides because they come after lanthanum. And these are the actinides because they come after actinium. This part in your textbook, you just need to read. It gives you some interesting, well, maybe you don't find it interesting, but some interesting properties, and it just talks a little bit about these different named groups in the periodic table. The alkali metals are very reactive. They will react with water. This is sodium and water. It actually bursts into flame. It reacts so violently with the water, generating hydrogen gas, and then there's so much energy released that the hydrogen gas begins to burn. And so, you definitely wouldn't want to make like a fire truck out of sodium metal, right? Because when it got wet, it would explode, and that would kind of defeat the purpose of having a fire truck. I don't know where these things come from. Alkaline earth metals, also reactive, but not as much. Magnesium is really fun to burn. It gives off a really, really bright light. If you put calcium metal in water, it will react with the water, but it just generates a lot of bubbles. It doesn't actually burst into flame, so they're not as reactive. The halogens are nonmetals. The other piece of information we can get from the periodic table is the state of that element at room temperature. There's a color coding on this one on the wall. All the red elements are gases at room temperature. The black ones are solids, and the blue ones are liquids. And so among the halogens, we see gases like chlorine. Bromine's a liquid, and iodine is a solid at room temperature. Then we got the noble gases. The noble gases just really don't react with much of anything. They're a little bit like the European nobles, right? The kings and the queens and the dukes and the duchesses, and they just hang out with each other, and they don't associate with the rest of us, right? They're noble. They don't need us. So we'll carry that analogy over when we talk more about bonding. Okay, so those named groups, we need to remember what they are. So which group or family does Li belong to? The alkali metals. Lithium is an alkali metal. How about B? B is boron. Is boron in a group that has a special name? No. Well, if we had to put an answer down there, is there a section of the periodic table that boron is a member of? How about main group versus transition? Boron is a main group element. So that's one of those. Well, that guy doesn't really fit the question. How about iodine? Iodine is a halogen. And Ar is argon. What group does argon belong to? The noble gases. We could ask questions too, like, which period 3 element is a halogen? So period 3 is row 3, and then the halogens are column 7A, and so the period 3 halogen is chlorine, things like that.